supersonic passenger air travel, most people will think of Concorde, the joint British and French design plane which operated from 1976 until 2003. And up until this day has been the only long-term supersonic passenger jet service to operate anywhere in the world. What many people don't know is that in the 60s and 70s there were 3 other competing designs from the United States and Russia. The Russian Tupolev Tu-144 was the first commercial supersonic transport aircraft, or SST, which had its first flight 2 months before Concorde on the 31st of December 1969. However, after a crash at the Paris Air Show in 1973 and another in 1978, it was grounded after just 55 flights, although it has remained in service as a research platform well into the 1990s. The other 2 American designs are less well known about because despite a huge government backing and that supersonic transport was meant to be the next big thing after the moon landings, neither of the designs by Boeing and Lockheed made it into the air. The story starts in 1962 when the British and French governments announced that they would jointly build a new airliner that could travel at twice the speed of sound and which would be called Concorde. This was to be the most advanced civilian aircraft in the world, showing that European aircraft manufacturers could create the most leading-edge designs, something that the Americans believed they were the best at. When President John F. Kennedy found out that Pan Am wanted to buy Concordes, he was so annoyed that he called up the Pan Am boss, who told him that if there was an American alternative, he wouldn't have to go to Europe to buy the planes he wanted. To meet this new challenge and to rescue American national pride, President John F. Kennedy stated that America would build its own supersonic transport aircraft and that it would be both bigger and faster than the European design. 2 designs, one from Boeing and the other one from Lockheed, were selected for further development, and as an incentive, the US government said that it would pay for 75% of the program's cost. The Lockheed L2000 design was almost a scaled-up Concorde and intended to fly at up to Mach 3 or 2,300 miles an hour whilst carrying 270 passengers for a range of 4,000 miles. The development of smaller fighters like the French Mirage 3 and the Russian MiG-21 had already proven the delta-shaped wing, similar to Concorde, could easily go to Mach 2 and beyond, and this was the route that Lockheed chose. Boeing, on the other hand, opted for a much more complex swing wing design that would be straight at low speeds, which would improve the takeoff and landing, and then swing back to become a delta wing as the speed increased. Boeing's 2707 design was supposed to be able to fly at Mach 2.7 or 2,000 miles per hour and carry more than 270 passengers for more than 4,200 miles. After much testing, the Boeing 2707 design was chosen as the winner on the 1st of January 1967. Progress, though, was far from smooth. One of the main features that the 2707 was meant to have was its ability to fly hundreds of miles an hour faster than Concorde, but this then created huge implications for the plane. Kit Mitchell, who was the principal scientific officer at the then Royal Aeronautical Establishment in the 1960s, also worked on Concorde. Kit said that the Boeing 2707's main problem was that it was trying to do too much, and so much of the technology that was required was still in its infancy. Military jets could fly supersonic, but even then it was only for a few minutes at a time, and not for a 4-hour flight like the airliners were expected to. The technology required to do this in the 1960s was almost as much of a challenge as sending a man to the moon. Concorde got around many of these issues because even though it flew at Mach 2, it wasn't so fast as to require exotic materials and brand new untested designs. Concorde was effectively the next step up from the V-bombers which the British had already developed. One of the biggest issues was the extra speed that was required. Concorde flew at Mach 2 or 1,350 miles an hour. The Boeing was meant to fly 650 miles an hour faster. Due to the compression of the air, many of the fuselage parts on Concorde were heated to over 100 degrees centigrade, and the nose tip alone reached 127 degrees centigrade when cruising at Mach 2. The body of Concorde was 300 millimeters or approximately 1 foot longer at supersonic speeds than it was when it was on the ground. This expansion and contraction of a body could lead to metal fatigue if not carefully maintained. It also meant that Concorde had a relatively short airframe life of 45,000 hours compared to 100,000 hours for that of a Boeing 747, and that would have an impact on the overall running costs for the airlines. Everything from the window seals to the electrical wiring had to be designed for a hot plane. Because Boeing was going to travel so much faster, they couldn't use aluminium, but instead the plane would be made from titanium, which would also push up the cost dramatically. Also, the swing wing design, which worked well on smaller two-seat fighters, when scaled up to a 300-seater airliner, needed to be so big and strong that it made the plane too heavy to be viable. So after a huge amount of work, the designers had to drop the swing wing design and return to the drawing board and go back to the delta wing design of the Lockheed and the Concorde. By the time the Concorde was in flight testing and the Boeing was still in the design phase, people had become all too aware of the sonic boom created by these planes, and it was going to be too much of a problem, and as such, supersonic flight over land was banned in most countries. This meant that the only viable routes were over the Atlantic from the east coast of the United States to the west coast of Europe. With these limited routes, the amount of seats that could be sold was greatly reduced, and the prospect of supersonic flight was dealt a huge blow. But what really finished the Boeing and the Concorde in the end, even before the one and only crash of the Air France Concorde in 2000, was the cost of the fuel, and travelling at supersonic speeds uses a lot of it. With the inefficiency of jet engines at low speeds, Concorde burned 2 tons of fuel just taxiing to the runway, and the Boeing was also going to be a very fuel-hungry plane to operate. The thinking at the time was that if you could fly to your destination in half the time, then you could do twice as many journeys and charge a premium, so fuel efficiency was not a top priority. When the supersonic designs were created in the 1960s, fuel was cheap, but by the time the 1970s arrived, when they were due to be coming into service, the price had risen. Together with a recession of 1971 and government cutbacks, it ended up terminating the Boeing 2707 project. The 2 Boeing prototypes were never finished, and with both the loss of the government contracts and the recession of the civilian aviation market, Boeing ended up cutting over 60,000 jobs. The Boeing 2707 became known as the plane that almost ate Seattle. As a result of the mass layoffs and with so many people moving away from the city in search of work, a billboard was erected near the SeaTac airport in 1971 that read, "Will the last person leaving Seattle turn out the lights?" Ironically, the plane that saved Boeing from going bankrupt was originally thought of as just a stopgap measure while supersonic planes took over air travel. That plane was the Boeing 747 jumbo jet. Despite the project's failure, Boeing learned a lot from the 2707, and much of it made its way into other experimental vehicles that the aerospace giant built in the following decades, including some of the unmanned vehicles built in recent years. The supercritical wing, a design tweak that came out of the 2707 project, is now routinely used on modern airliners to limit shockwaves and reduce drag, while Lockheed's ill-fated L2000 design will also live on thanks to a collaboration between NASA and Lockheed to fly an experimental demonstrator to research the future of supersonic aircraft. So maybe, in years to come, a US-built supersonic airliner will finally take to the sky.